name's Warner, and you're watching my Assessment 9 video for Information Systems 410X as part of the Undergraduate Flex degree. In this video, I'll be summarizing my answers to some questions about distributed database management systems that were posed in a prior assessment. With that, let's get right into it. The first thing we should recognize are two major strategies or styles for a distributed database management system, or DDBMS. A DDBMS is an expansive database where clients, data, users, and equipment are distributed throughout multiple sites. Homogeneous systems have the same database management system, or DBMS, at all sites. These are often easier to implement because software and systems are congruent between sites. What works at one site may very well work at another site. As the graphic suggests, all sites have the same DBMS. Heterogeneous systems have differing DBMSs throughout the sites. These systems do work, but they can be harder to implement because all DBMSs do not play nicely with each other. This graphic demonstrates multiple sites, each with a differing DBMS. All DDBMS systems have a few things in common. The most important are how they store data and the relationships that data is given. The table format allows individual records to be sorted by row with varying characteristics. You can use indices and primary keys, for example, which allow relationships between records and tables to be made. This allows the data to be distinguished and correlated. When talking about these systems, you might ask, who's actually using these? Well, use of DDBMS might be more widespread than you imagine. Basically, any mid to large size company with multiple sites is a prime candidate for use of a DDBMS. This is because each site will be required to collect, view, and correlate data both individually and collectively with the organization. How the data is separated could be by function, specialty, or geography, and since this uniqueness occurs, a distributed model works well. Many companies, including those you're likely already familiar with, are using DDBMS systems. A few examples are Kraft, Boeing, and Chevrolet. Now you're probably asking, why not use one database in one location and just have remote sites access it? Well, that's a good question. The DDBMS model allows the collection of data from a wide variety of sources. Not all of that data is relevant in terms of location, type, or usefulness to other locations or sites. Not all of that data should be accessible to all members of an organization. Therefore, DDBMS systems can be arranged such that Site A focuses on data from customers in their region, while Site B focuses on data from another area. Due to the requirements in each area, Sites A and B may use different DDMSs, and their data might not be needed by the other site. Among many, two major reasons for distributing systems in this way is to be economic and for the sake of security. If Site A uses predominantly data collected in its own region, it might not be cost-effective to have the infrastructure and bandwidth to be frequently accessing data at a central or remote site. From a security perspective, Site A may have no need to see the majority of data at Site B, so the separation of data is warranted. C.J. Dates, following in Codd's footsteps, developed 12 rules for DDBMSs. I'd like to look at 3 of those now. Rule 9 is hardware independence. This suggests that the DDBMS should run on basically any hardware. In my experience, the technology industry seems to be converging in support of this goal. While there used to be many special and brand-specific architectures and chips and hardware, there are now fewer, and there is much better support across these differing platforms. Many systems used to use their own hardware, but now Macs and PCs both run on Intel CPUs and NVIDIA graphics, for example. Many programs and systems are now hardware agnostic. Rule number 10 is operating system independence, which means the system should run whether you're using OS X, Linux, Windows, or another operating system. In general, there aren't a ton of languages with great cross-platform support, but it's improving. Many companies now release multiple versions of their software for each platform, while keeping file specifications and protocols similar for sharing files between platforms. Rule 11 is network independence, which suggests that systems should operate independent of networks. In general, there's pretty good support for this, since the internet and communication protocols are very well defined and adopted. Rule 12 is DDMBS independence, which suggests that a DDMBS should be able to operate regardless of which DDMBS system is used throughout it. This one is tough, because DDMBSs don't always play nice, and there's really no such thing as an authoritative translator between all DDMBSs out there today. Now that I've talked a bit about DATE's rules for DDMBS, you might be wondering if any system out there actually follows them. The short answer is no. There are some software systems and software-defined networks which are approaching good compliance with these rules, but with so much variety, a one-size-fits-all solution is nearly a technological impossibility. There are so many factors and variables that prevent easily reaching a system that adheres to all 12 rules. The last item I want to touch on is commercial versus open source DDMBSs. There are a bunch of widely developed, widely used open source DDMBSs available, but they aren't all congruent with their commercial counterparts. Many have specialties and focus on a particular task, such as mobile apps or product catalogs, and others are highly extensible but lack in performance. An example of a few open source databases are MySQL, MongoDB, and PostgreSQL. That's all for now. I hope you enjoyed this short video about DDMBSs. Thanks for watching.